looking at properties of exponents. And what does properties of exponents exactly mean? Well, in the event that you have to either multiply or divide with exponents involved, you're actually going to be doing some adding and subtracting first, which sounds a little bit confusing. I am going to post a resource with the video that will go through all the laws of exponents, and it even goes back to a video we did about integers in exponents, because we're going to see negative integers with some of these exponents as we move forward. It'll be very helpful. It's actually one of the more important lessons when it comes to exponents now that we're moving into the pre-algebra and algebra stage. So stay with me. I think if you take it slow and maybe rewatch the video a couple times with your homework or studying summer math packets and all that stuff, you should be okay. Leave a comment if there's something that you haven't seen though, because there's a lot of things that could be gone over here. Otherwise, I think you should be okay. Please make sure you do me the favor of subscribing, commenting, sharing it out. It will definitely help me out. Thank you. All right, before we actually start talking about properties of exponents, let's go through the list of the laws of exponents. So in some cases, you'll be asked to multiply two exponents together, and notice that your bases are the same. They have to be the same in order for this to work. So if we took 2 to the second power times 2 to the third power, you're not actually going to do anything with the 2's. You're just going to bring those together. I'll write this over here. And you're going to take your exponents and add them. So when you're looking for the product, you actually add your exponents together. All right. In the event that you have the quotient, so let's say that you have 2 to the third power over 2 to the second. All right. In this event, you're actually going to keep the bases the same as 2, but you're actually going to subtract your exponents, the top from the bottom. So 3 minus 2 would be 1, so it's 2 to the first. All right, and then when you're taking the power of an exponent, what you're going to end up doing is taking, let's say that you have 5 to the third, and then you're raising that as well. You're going to take the 5 and the 4 and the 3. You're going to take the 4 and the 3, and you're going to multiply those together, so it's now 5 to the 12th. We stated this before in another video that anything raised to the 0 exponent is 1, and then negative exponents get dropped to the bottom, which we did a whole video on, so you can go back and check that out. All right, let's jump into some of these problems here. So I will say that going back to that reference sheet will definitely be helpful. Otherwise, it's pretty straightforward. So right now we're just going to rewrite these as 1 power. So the x is going to stay the same, which is our base. Now, we notice that this operation tells us that we're going to take this and this, and we're going to add them together. So it's now x to the 18th, all right? Because our exponents or our problem is being multiplied, so we take the exponents and add them together. Same thing here, slightly different, that our d will stay the same. Take note that this d is not 0, but it's d to the first power, all right? Then we're going to take our 5 and our 1 and subtract. So it's d to the 4th power, and that's all we're going to do right now, okay? This is just another way that division is written. So we have a negative k, which is completely fine. So note that it's division. So it's 12 minus 9, which simplifies to k to the third. All right, now this one's a little different, all right? So once again, it's division. So we can do c, 4 minus 6, and you can see that's going to be a bit of an issue here. So when we simplify that, we have c to the negative second. Typically, you don't want to leave something with a negative exponent. So going back to our video on negative exponents, we're simply going to bring this down to the bottom since it's a negative exponent, and it's now 1 over c to the second. All right, let's take a look at these ones. So once again, that exponent or laws of exponent rules will help. That now we're actually doing exponents within exponents, so to speak, that we're going to take the 7. Obviously, it's going to stay the same. We take the 3 and the 4 that are exponents, and we just simply multiply them together, and we're just going to do 7 to the 12th. All right, we're not going to do anything further with that unless specified to do so. Same thing here. We're not dropping anything to the bottom yet. All right, so we have 8, 4 times negative 2, ends up giving us 8 to the negative 8th power. And typically, I would have the kids or students have this drop to the bottom, so that way we have all positive exponents. All right, now with this one, same thing. You're going to see things are a little different here. We have 0 times negative 2, All right, so that ends up being 12 to the 0 power, which really you could just might as well simplify that and make it 1. All right, this problem is much more difficult than it looks. So it says Megan and 99 of her coworkers, which brings it up to 100, of her coworkers won the lottery worth 10 to the 8th power. They all received their winnings over 10 years. How much did each person receive in 1 year? All right, so if it's Megan and 99 of her coworkers, it's 100. So we know that the lottery was worth 10 to the 8th power. Well, if they're splitting that amongst each other, we could write 100, but let's make it as an exponent, so 10 to the 2nd power, all right? So we know that with our laws of exponents say that we're going to subtract the 8 and the 2, now leaves us with 10 to the 6th. And then they're going to split that. We want to see how much they're going to earn over the course of 10 years. So that's 10 to the 1st, all right, because it's really just dividing by 10, but since we have exponents. So we go ahead and subtract again, so it's 10 to the 5th. So over the course of 10 years, they're each going to be getting, I miscalculated here, they're each going to be getting $100,000 a year. So definitely enough to quit their jobs.